give the answer. That is very important. So most of you, very good. So what you'll be thinking is, so others will give the answer, why should I involve in that? So it is not the right way I'm saying it. So design is such a subject, I'll keep on repeating this statement. Design is such a subject, whenever you interact, you'll get more. Okay, not when your friends interact. Okay, they will interact, they will run. So similarly, every one of you, please do interact whenever there is a chance and whenever I ask you a question regarding that. I hope it will be not a tougher question which I'll be asking. It is very simpler question, so please do interact. Okay. So we shall check for the module and start the problem straight away. So we have selected module number 5 initially. So we'll start checking it. So why we need to check it? Because since CV was assumed, so we shall have to check for design stress. Okay. Now for that you take this particular expression, you know it very well. So pi sigma d CV B Y and M. Okay. So from this calculate the value of V, which is pi d1 n1 by 60. Come on. So it is pi cross d1 is 0.08 cross 1200 divided by 60. So V you get it as 5.03. And why you are calculating V? Just to calculate your CV. So take the formula for CV from your data handbook. It is 3.05 divided by 3.05 plus V, and this particular formula is for V less than 8 meters per second. And I will not be able to write everything on the screen because it is very difficult, guys. If I have, even though I have this sort of arrangement, iPad and a pencil, it's really tedious for me to write everything on the screen. Okay, it's really hard. So that's why I request all of you to write each and every statement, each and every equation numbers from which you are taking the data. Okay, give me the value of C. So it is 3.05 divided by 3.05 plus 5.03.
0.377.
0.377. Next, what you have to do? Calculate the value of F. So Ft is equal to, it is 2 times of MT max in the problem, because he says something 20% greater and all stuff. So take that particular thing into consideration. So 2 into 191. So this is an upgraded value for 20%. Okay, so directly taking that. So now what is the value? Newtons.
4775.
4777, huh?
5.
Okay. So substituting that equation, 4775 is equals to sigma d1. You are supposed to calculate cross 0.3775 is the value of CV into 50 is the phase width, and 0.3047 is the value of Y cross phi. So just give me the value of sigma d1 and take care that this should be less than your design stress, which is 233.4, which you have selected the material upon. Okay. 166. Okay. Then it is, I can say, it is since the calculated value, just write the sentence, since the calculated value is less than permissible stress, so we will assume, therefore the assumed values are satisfactory. Just write this particular sentence. After that, so second bit he has asked to calculate the phase width, which you've already done it, but just to please your evaluator, what you do is just write to find face width. You already done it, but put it in a proper format. B is equals to 50 mm. Just show it and put it in a box so that your evaluator comes to know that you have done it. Next is to find the dynamic tooth load. To find dynamic tooth load, which is the value of EFT. Take by that particular equation, you know it very well. So it is EFT. Kindly write the equation number, guys. I cannot look here every time. Okay, so that's why FT plus K3V into CB plus EFT divided by K3V into square root of CB plus FT. In this all, so K3 value is fixed, that is 20.67 for all the problems. It would be same. Next, I want the value of C, guys. Now it's a task for you. You want the value of C. So for that, how we have to do? You have to go for the table. What was the table number? Forgot. Here it is. Okay, so you cannot calculate directly the value of C. You have to calculate the value of V first. So from V, you have to take up the error. Just a minute, I need to call HOD. You be calculating the value of this thing C, guys. Okay, I'll just come back. Okay. So what is the velocity? 5. So for 5, it is 0.64. Correct? The error value is 0.64. Okay. Now come back to this particular table. For what you have to select, for 20 degree, it's full depth, right? So it is full depth steel to steel combo. So just remove all those stuff which is highlighted. Now we have to go for 20 degree. 20 degree in the sense it is this full depth. In that steel to steel combo is this. So I'll just highlight that particular. So steel to steel in this particular line you have to look for. And the error is how much? It is 0.064. 0.064. Okay. 1 second. Okay. Now, the value was 0.064. Okay. And you have the value for 0.06 and you have the value for 0.08. But I need the value for 0.064. So how to do it? So we'll just take up that particular method once again. Okay. So just note down the value for errors. For 0.06 it is 686.7. For 0.06 it is what? 686.7. 686.7. And for 0.08 it is 915.6. For 0.08 it is 915.6, but I require the value for Z, which is how much? 0.064. 0.064, correct time. So I have taken this as x1, this as x2, this as y1, and this as y2. Now pick that particular formula. Yes, here it is. Okay. So I would just take this. So is equals to y1 is how much? It is 686.7 plus z value we have to decide upon 0.064 minus x1 value is 0.06 divided by x2 minus x1 is 0.08 minus 0.06 into y2 minus y1 is 915.6 minus 686.7. Okay. What is the value of C? What is the value of C? 732.48, isn't it? 732.48. So this particular method, what we have framed is easy for you to get values, I guess, right? So everyone are comfortable with this particular method, through which we pick a value which is intermediate in nature. Okay, good. Okay. So once we have calculated the value of C, anything else we require in this particular big formula? I guess not just substitute all the values in this particular equation. We'll be calling it as equation number 1. So whatever we have grabbed the values, just substitute each and everything and give me the value totally. So ft is equal to 47, that is the value of ft, plus 20.67 into 5.03 cross 732.48 we have taken the value of into 50 plus 4775, okay, and this whole divided by 20.67 into 5.03 into square root of 732.48 cross 50 plus 4775. Yes, guys. So give me the what is the value of dynamic load directly in the form of kilonewtons.
Hello, Matsudan, one nimisha.
Yes, sir.
Hello,
Hey, sir.
Matsudan. Okay, class ಅಲ್ಲಿ
Yes.
ಸ್ನೇಹಲ್ ಶೇಟ್ ಇದನಾ?
Snehal Shet.
Manjunath is there. Hello, Mr. Manjunath. Please switch on your mic. Manjunath. Hello, Manjunath. Please switch on your mic. Hello, Manjunath. Sir, Manjunath class ಇಲ್ಲ.
Class ಇಲ್ಲ sir. ಅವನಿಗೆ absent ಹಾಕಿ.
Absent ಹಾಕಿ. Some students are they're doing mistakes like this. At the end of the day, ಅವರಿಗೆ ಸಬ್ಜೆಕ್ಟ್ ಅರ್ಥವಾಗಲ್ಲ. Then failures ಗೊತ್ತಾಗ್ತಲ್ಲ ಹೇಗಿಂತ ಈ ಸಬ್ಜೆಕ್ಟ್ಗಳು ಡಿಸೈನ್ FEM heat transfer. If they do like this, they cannot understand anything.
ಅವ್ರ ಮಾರ್ಕ್ ಮಾಡಿ ಇಟ್ಕೊಂಡಿದ್ದಾರೆ ರೆಸ್ಪಾಂಡ್ ಮಾಡಲ್ಲ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಅವ್ರಿಗೆ ಸೆಪರೇಟ್ ಆಗಿ ಒಂದು ಮಾರ್ಕ್ ಮಾಡಿ ಇಟ್ಕೊಂಡಿದ್ದಾನೆ.
ಓಕೆ.
ಸೊ ಆಯಾ ಪರ್ಟಿಕ್ಯುಲರ್ ಕ್ಲಾಸಸ್ ಗೆ ಆಬ್ಸೆಂಟ್ ಬೀಳ್ತಾ ಇದೆ ಸರ್ ಅವರಿಗೆ. ಬಟ್ ಯೆಟ್ majority of the students are giving the answers, but there are some few 10%
ಈ ಕ್ಲಾಸ್ ಪರವಾಗಿಲ್ಲ, ಸ್ವಲ್ಪ ಇಂಟರಾಕ್ಟಿವ್ ಆಗಿದ್ದಾರೆ ಹುಡುಗರು. ಬಟ್ ವೆರಿ ಫ್ಯೂ ಸ್ಟೂಡೆಂಟ್ಸ್. ಮೊಹಮ್ಮದ್ ಫಜೀಲ್ ಅಲಿ is there in the class?
Muhammad Fazil Ali. Illa sir, class illa.
See, that is one by you need to consider it.
Sure, sir.
Write a mail to their parent as well as to him. Mark a copy to me.
Okay, sir. Fine.
Then Mohit, yes.
Mohit, yes.
Not regular. Just check. Srinidhi. Snehal. And this Manjunath.
Yes, sir. We are really regular, sir.
How many classes Mr. Snehal has attended your class?
I'll just check, sir.
You can tell me. I'll take another 1 minute, that's all. I don't
Sure,
disturb you. Only 54 students out of 68. 40 members absent. What is this?
Manjunath ಅವರು 5 classes attend ಆಗಿದ್ದಾರೆ sir out of 11.
Out of 11, sufficient. Yes. Not even 50%.
Not even 50%. 46 is the percentage.
Okay.
And
you write email serious mail to him. Okay.
Sure, sir.
Make a serious mail to him and mark a copy to me. Then.
Okay, fine. Snehal to 7 classes ಇದೆ sir out of 11. So 64% is attendance here.
Are you taking regular class? ನೀವು ಸರಿ ಅವರ ಹೆಸರು ಹಿಡಿದು ಕರೀರಿ better.
How is it?
Can you identify someone gives a yes answer to you?
Illa sir, it is completely different procedure what I follow for the attendance sir.
How do you do?
So Google Sheet ಗೆ ಒಂದು sheet ಗೆ ಎಲ್ಲರಿಗೂ share ಮಾಡಿದ್ದೇನೆ sir. I can present it now for you.
Okay.
So ಅಲ್ಲಿ ಆಯಾ ಸ್ಟೂಡೆಂಟ್ ಕಾಲಮ್ ಗೆ ಅವರವರು P ಅಂತ ಮಾರ್ಕ್ ಮಾಡ್ತಾರೆ sir. Whenever I give a command to mark your attendance within a span of 3 minutes sir.
Okay.
So I will come to know who has edited it.
Okay.
So they cannot mark the attendance for the other cell, nor they can select their own cell. ಅದು ರೆಕಾರ್ಡ್ ಇದ್ದೇ ಇರುತ್ತೆ ಸರ್. ಎಷ್ಟು ಕ್ಲಾಸ್ ಮಾರ್ಕ್ ಮಾಡಿದಾರೆ ಅವ್ರದೆಲ್ಲ ನಮಗೆ ಹಿಸ್ಟ್ರಿ ಗೊತ್ತಾಗುತ್ತೆ ಸರ್ ಟೋಟಲ್.
Okay, that's better.
Yes, sir.
Better. How the class is going on, my dear students? Any one of you can give the feedback?
It's going good, sir.
Going good?
Good, sir.
Very nice. Subjects are interesting, especially for 6th semester. All subjects are very much interesting. Only thing you need to be alert, my dear students. We have provided good faculty to you. Then some of you are not regular. I am not happy with a few of you, my dear friends. Definitely, I am not happy. When the department is taken so much care to provide the best, why you are not making use of this? Please make use of this. Okay. All right, Matsuda, please carry on.
Thank you, sir. Okay then. So have you calculated the value of FD? It's been a lot of messages. I should scroll up again. 4.96, huh? Is that the value, Bhairvan?
That is in kilonewton, sir.
Achha.
Yes, sir.
Okay, so what is the value of FD then? What is the value of FD?
18.7.
Okay.
4.97, sir.
4.97. Yes.
Formula missing.
Sir, before square root, you should put plus, sir.
Acha, yeah. It's my mistake. Huh? Okay, fine. Now.
$18.7, sir.
18.7 kilonewtons. Fine. Okay. Is this the value? Everyone is getting the same value now? Those I got 4.96. Please check before I move on further, because the value of 50 is very important. I told you all of the values should be less than this particular value. Okay. Is that correct value? Okay. Next, to check FD, we need to find what we need to find, whether it's load or not. So in order to check that particular thing, we need to find endurance strength. Okay. So that is FEN. So calculate this particular value. FEN is equal to sigma EN B capital Y and M. Now at BHN a value of 200, since you have selected the material, isn't it, as 200, give me the value of sigma EN from the table, from the data handbook. So once you get that value, you can calculate your endurance load easily. Cross 50, Y value was 0.340, sorry, 3047. 3047 cross 50 module. Give me the value of FAN in the megapascal. 345. That's great. So from where did you get that value? The table number. 12.15. Okay, here it is. So in this particular table, I'll just remove all this. So for the value of 200 and for the steel, so you have selected the value as 235, 345. That's fine. So taking it as 345. What is the load of FEN? .28, okay, 28 kilonewton. Now, whether it is greater than dynamic load, so just write this particular sentence. Since FEN is greater than FT, the material is safe against static tooth load. So the material is safe against static tooth load. Next, you have to check for wear, isn't it? And the last step is to check for wear. So after that, make it fast, guys. I need a lot of time for that particular game, so make it fast. So ES now to find the wear load. So that is FWF. Okay. FWF. So FWF is given by, take that particular expression, D1, B, K1, K. So D1 is 80 mm, you know that. K is nothing but 2 times of Z2 divided by Z1 plus Z2. So that is 2 times of 48 divided by 16 plus 48. So that is equal to 1.5. Okay. Pick the value of K now. The value of K from the data handbook. So what is the table number through which you can pick the value of K? Here it is. I'll just drop all this. Okay, now for steel and steel combo in the sense it comes all this stuff is steel and steel combo itself. Okay, for all this combo. Okay, and for 20-degree involute system. Okay, and BHN value 200. BHN value 200. K is how much? Just for 200. Okay, for BHN value 200, for steel and steel combo, the value would come down to 0.539 for 20-degree full depth involute system, right? Now, K is equal to 0.39. So from where taken? From data handbook, table number, just write all the stuff, it's very important. 12.16239, 12.16 base 239, steel combo, that is 200 BHN, and for alpha is equal to 20 degree is the value. Now calculate your FW now. So 80 cross 50 cross 1.5 cross 0.539. So FW is equals to how much? 3.23, right? 3.23 kilonewtons. Now, whether this particular value is acceptable for the wear load? No. So why? Because it is very much less when compared to the dynamic load. So dynamic load is what? 18.76 kilonewton. It has to be more than this, but it is too much less than that. In such situations, what you have to do, you know that you can just write a sentence since FW is lesser than FD. The pinion is subjected to rapid wear and hence has to be surface hardened to higher BHN. So that means you have to increase the value of BHN. So how do you do that? So just take FD expression, it should be greater than or equal to FD, right? Okay. So D1, B, K should be greater than or equal to 18.76 kilonewton. In the sense it is 10 to the power of 3. Now it is 80 cross 50 cross 1.5. K should be greater than or equal to 18.76 into 10 to the power of 3. Now K should be greater than or equal to what value? K should be greater than or equal to what value?
.12.
Okay, it is 3.12. Now, what you have to do, again therefore, for steel and steel combo, you have to go in reverse, having alpha is equal to 200 and K is greater than or equal to 3.126. Give me the value of BHN of pinion and the BHN of gear. Okay, you have to go in reverse now. Where is that data handbook? Is the value of 3.126 for 20 degree involute system? Just go for 3 point something 126 alva. So you go for a little bit higher value, 3.126 and 3.226 then. So just come back and note down the values of BHN of the pinion and gear. So it should be 450 around. So just write that particular value there. It should be 450. And there ends your problem. Understood, everyone? Any doubts in the spur gear design problems? So we'll be ending up the spur gear here. In the next class, we'll be studying the helical gears. Okay. So any doubts if you have in the spur gear, you can discuss now, or else we can jump to a game now. Okay. Okay. Then I'll stop the recording.